Hello everyone, welcome to this lesson. I hope you are all doing very well. In this lesson we are going to be determining the equation of trigonometric graphs. So this is a typical exam kind of question. So when you look at this picture of these two graphs, I know it can be overwhelming. It's a lot, but you just got to try relax and slowly try and absorb the information that they're trying to give you. So in essence, what we have here is we have a graph of f, okay, and they've given us that that's the red one, and a graph of g. Now that's going to be the blue one. Now we know that in any trigonometric graph there are 4 parameters that they can test us on. So if we just write out the general formula, we know that there's an a. Okay, I'm actually not going to talk about letters, but we know that there's this part in the front, or this letter in the front. There's this letter over here. There's this letter and this letter. Don't become too into the A, K, because each textbook can change that. But what you need to know is what the different letters do. So in the first one, they've given us the parameter A, and they've given us the parameter P. That means that the graph has been stretched or compressed vertically, and it's also been moved over left or right, right? Because that's what that P does. It moves the graph left or right. So that red graph is a graph that, so I'm just going to write here red. That graph has done something like this. It's most likely been stretched in the vertical direction, and then it's been moved over, okay? We don't know if it's left or right, or if it's been compressed or stretched, but that's what's happened to that one. If we look at the blue graph, well, what we can see there is that it's got this parameter here, the K and the Q. So we know that the K, well, that stretches or compresses in the horizontal direction. So it's done something like that. And then it's also got a plus Q. Now we know that that moves the graph up or down. So let's just say it goes up. And so we've got something like that happening. So let's get started with the red graph. And remember what we said in one of the previous videos is that you can solve each letter separately. So you don't have to go solve it all at once. You just have to solve it separately. So for the a value for f of x, we know that that stretches in the vertical direction. So all we need to do for that is look at the vertical length. So we know that a normal sin graph has a maximum at 1 and a minimum at -1. So that vertical length is 2. So if we look at this red graph, well, it's got a maximum at 2 and it's got a minimum at -2, okay? So we can see over there they've got a -2, and so that is a vertical length of 4. That means that they have doubled the graph, and so straight away we can say that a is equal to 2, because they've doubled the graph. So we now have, or let me use f of x, we now have the a value. Now that a value is not going to help us solve for p. Remember, each parameter can be solved by itself. So now p is something that moves the graph either left or right. And so we need to keep in mind what an original sin graph looks like, and then we just need to find one point that we can compare with the original. So for example, we know that this coordinate here is usually at 90 degrees. Okay, I'm not going to worry about the y because we've already looked at that. So that's usually at 90. This one is at 60 degrees. Can you see that? That same point is at 60 degrees, which means that this graph has moved 30 degrees to the left. So what that would mean is that that equation must have f of x equals to 2 sin of x plus 30, because remember when you plus 30 it actually means 30 degrees left. And so there we go, we have that equation solved. Notice how we solved each parameter separately. F of x is now complete. Now we can move on to the cos graph, which is the blue one. So you can choose whichever parameter you want to do first, because remember, each parameter can be solved separately, which is nice. You don't need to know the one before you get the other. So let's try find k first. Now we know that k causes the graph to either elongate or stretch in the horizontal, or it can cause it to compress, so it can become a little bit shorter. What we need to do then is try to determine the period of this blue graph just by looking at it. So we need to find 2 points that are in phase. So what we mean by that, for example, is this point over here and this point over here. Now those 2 points are 180 degrees apart. So what we can say then is that that blue graph is taking 180 degrees to repeat. That is a cos graph, and a cos graph normally takes 360 degrees. Okay, so what number can you think of that links 180 and 360? Well, some people might say half and some people might say 2. Both of you are technically correct, just depending on the way you look at it. But what we must remember is that x's are complicated. So the logical thing would be to, like if you were explaining this to a grade 4, if we say that the graph has become shorter, you would want to choose a half. But x's are complicated, so we are actually going to replace k with a 2. Okay, so that 2 implies that the graph has actually become shorter, twice as short. And so g of x is going to be equal to cos 2x plus q. Another way to remember it is that there is a formula that says that the period, or the period new, is equal to period old divided by k. So the period new, let's say we didn't know what that, or no, let's say we know the new period. We said that was 180. The period old, well, that's a normal cos graph, that's 360, and then you get k. If you had to go solve for k, you would end up with 2. And now lastly, we can find the parameter q. You see, so this is actually very easy. You just do each part separately. So we know that q moves the graph upwards and downwards. So if we looked at a normal cos graph, we know that that cos graph would have to go between 1 and -1. If it was stretched by a factor of 2, then it would go up to 2 and down to -2. But remember, the parameter in the front of this cos expression over here, that's still, they haven't given that as a parameter, which means that this graph has not been stretched. Okay, so we know that a cos graph goes between 1 and -1, but if we look at our cos graph, it is going between 0 and -2. So how do you go from those coordinates, so 1, -1, how do you turn that into 0 and -2? Well, you move the graph down by 1, because if this point moves down by 1, it becomes a 0, and if this point moves down by 1, it becomes -2. So that whole graph has moved down by 1. And so there we have it. We have worked out the equation of both graphs. Notice each parameter was solved individually. Each of the 4 parameters do not have an influence on the other. Okay, I know I've repeated that a lot, but it just makes life very simple if we look at it like that. Now we can move on to question number 2 because we've done number 1. So it says, for which values of x and r, everyone loves these questions. That was a joke. So for which values of x is f of x greater than g of x? Okay, so first of all, you must make sure that you understand that this means greater than, okay? So f of x greater than g of x. What that means is that f of x is, or let's first look at what f of x is. F of x is a y. Remember, f of x stands for a y value. G of x is also a y value. So what they're saying is, where is the graph of f, the y values, where are they bigger than the y values of g of x? Now y values are in a vertical direction, okay, not a horizontal direction. So pretty much what it's saying is, where is the one graph higher up than the other one? Now what's something that's really cool is that the places where you have to look is, for a question like this, is the places where the graphs intersect. And so that's going to be at A, at B, and at C. Those are going to be the critical areas that we are going to need to look at. You don't need to look anywhere else for a question like this. So if we look to the left of point number A, okay, so we're looking to the left, which graph is on top? Well, for that entire interval, I see that the blue graph is on top. Okay, so the cos graph is high up. Can you see that? Here's the blue graph, whereas the red graph is underneath. So we're not interested in that interval. Why? Because we want f of x, which is the red graph, to be on top. If we now look in the next interval, which is between the letters a and b, so all of this, which graph is on top? Well, now it's the red graph, so we want that because we wanted the red graph to be on top. Okay, so we'll just remember that for just now. So that's one of our answers. Then we look at the next interval, which is between B and C. Now, there we're not interested in that because in between B and C, the blue graph is higher up. Can you see that? Here the blue graph is higher up, so we don't want that part. Then if we look to the next interval again, which is from C onwards, we see that the red graph is on top again. So we know where our answers are. It's between A and B and after C. So now we use x values to explain our answer. So we can say that x is an element going between a and b. So the coordinates at a are minus 102. Now I'll explain just now as to whether we should include brackets or not, and many of you saying, Kevin, well obviously we're not going to because this doesn't have an equal sign. Yes, but there's a little catch to this one as well. So I will explain that now. And then the x coordinate at b is 158. Okay, so we're going to go between minus 102 and 158. Then we're also going to include, so you can either do this, which stands for or you could just say the word or. And then we want to go from C. Now we're not going to go to infinity. Remember, you must always go within the domain that they've given you. So we're going to go from C up to 360. Because remember, it's not going to go to infinity. Because if these graphs had to continue, well, eventually this sin graph would turn back down and it would cut through the blue graph again. So we must stop at 360. But that's where things get a bit interesting. So we're going to go from 258 up to 360. But now the 360 we are going to include. Why? Because at that point, the red graph is still higher than the blue graph. It's not a point where they've crossed over, so we will include 360. So whenever you guys get a question like this, just go circle the areas where the two graphs cut into each other, and that's all you need to do. Those are the areas where the crossovers take place. You don't need to look anywhere else. Great, and that's all. Thank you for watching this video.